Hi dear students, dear YouTube followers. I will begin now with test number 2. It's about Unit 2, Production, Costs and Perfect Competition. Okay, let's start. Whenever the average total cost curve is over the marginal cost curve, well, we should do the graph. The typical graph is this one. Is very useful to understand this type of questions and to try to answer them correctly. When the average total cost curve is over the marginal cost curve, it happens until this level of Q, that it should be here, okay? Until here, the average total cost is here, while the marginal cost is here. It's always above the marginal cost, the average total cost curve. So, what does it happen until here? Is the marginal cost increasing? No, the marginal cost is increasing only from here to the right, not until here. So it's not completely true. The marginal cost is decreasing. No, it decreases until here, but not all the interval for Q. From here is increasing. The average variable cost is decreasing. No, the average variable cost, it doesn't decrease until here, because from here it's slightly increasing, yeah? So the correct one is D. Okay. Now, number 2, it's very similar. Whenever the marginal cost curve is over the average total cost curve, so we use the same graph. Whenever the marginal cost curve is over the average total cost, is from here to the right, it always marginal cost over the average total cost. Is the marginal cost increasing? Yes, from here to the right, the marginal cost is increasing. Even before, okay, yeah, but from here to the right, of course, it's increasing. The average total cost is decreasing. From here to the right, the average total cost is not decreasing, it's increasing. So C is also true. Yeah, the average total cost is increasing from here to the right. So both A and C are true, then we mark B. You could make this graph at home and try to understand, and try to answer to whatever question you may do yourself. Yeah, you could wonder what happens from the intersection between the marginal cost and the average variable cost to the right. You could wonder what happens until the marginal cost intersects with or until the minimum or the average total cost or whatever. You have to read the hypothesis, the assumption properly, and try to identify where does it happen, and in that interval or at that point, is one of the possible answers true? No. That's how you have to think, okay, to do properly these kind of questions. Now, very important question, very typical. Number 3, the long run production function is this one. It's a Cobb-Douglas type, yeah, L elevated to 2/3 times the square root of k, so k elevated to 1/2. Exhibits, well, when we have Cobb-Douglas type, and not only Cobb-Douglas type function, the function is homogeneous. It has only one sum, yeah. I don't know how you tell it in English. I don't have L plus K or square root of L plus 2L. We only have one sum. Then it's for sure homogeneous function. the degree of homogeneity is the sum of the exponents, 2/3 plus 1/2, and that degree tells us about the returns to scale. 2/3 plus 1/2 is, if we operated, 7/6, and as it is greater than 1, we have increasing returns to scale. The limit is at 1. Yeah, when the degree of homogeneity is over 1, we say that we have increasing returns to scale. When it is below 1, we say that we have decreasing returns to scale. So in our case is clearly B. In these easy cases, it's not necessary to prove by definition or to use the definition for the returns to scale. Yeah. If we did it, we should do like this. Let gamma be a number greater than 1. We have the function, but now not using L and K, unit of input, but gamma L, gamma K. Okay, we've increased the use of L and K at the same rate. Okay, returns to scale at the same scale. Gamma L, gamma K here inside, we take them out, and we have gamma elevated to 7/6 times this expression, that is the function we had before. So at the end, we have that gamma elevated to 7/6 times the function. We have to compare it with gamma times the function. As gamma is a number greater than 1, any number greater than 1, when we elevate it to a number greater than 1, it will be higher than itself or bigger than itself. So as the function with the new values of L and K is higher than gamma times the old function, we have increasing returns to scale. Yeah? Our production has increased by more than the inputs L and K have increased. Okay, we will see, I suppose, if I don't remember that, we will see some cases where we can't apply this trick. Yeah, so there we need to do to use the definition because we don't have that trick. Exercise number 4. Which of the following is the definition of decreasing returns to scale? Well, a firm produces less when it increases the use of its inputs at the same proportion. No. In fact, it's not very logical a firm to produce less than before. Yeah? Maybe it produces more, but that increase is not very significant. Yeah? A firm produces less when it increases the use of its inputs. No. A firm increases its output, its production, by less than it increases its inputs. Yes, this is the definition of decreasing returns to scale. The firm may produce more, but this increase in the output is not as high as the increase in its inputs. Okay, the inputs may increase by 50%, both each, but maybe the production increases only by 30%. That's what we have to look at when we are thinking about the returns to scale. Okay, a very, very important definition. Here you have the definition mathematically. Okay, for every gamma greater than 1, the output, the production, when I increase L and K at that rate is less than the old production with that increase. Okay. Well, number 5, the long run production function L elevated to 0.5 times 2 plus the square root of K exhibits. Well, this is the case I was telling you 1 minute ago. here we don't have a homogeneous function, okay, because here this factor, the parenthesis, we have 2, this degree 0, plus the square root of k, that is degree 1/2. So this factor has two sums with different exponents. It can't be an homogeneous function. So we need to use the definition of returns to scale, yes or yes. Okay. So let's begin. Let gamma be a number higher than 1. We use now gamma L, unit of labor, gamma K, unit of capital, then gamma L elevated to 0.5 times 2 plus the square root of gamma K. Okay. Well, if I want to take out gamma here, it's not very easy, or the square root of gamma. What I can do is to put, it's not the unique way to do this, okay? If you find an easiest way, it's perfect. If I multiply by the square root of gamma and divide by the square root of gamma, I can take out the square root of gamma. Yeah, I take out that, so that we have gamma elevated to 0.5 times this square root of gamma. We can write it like this: gamma elevated to 0.5 times L elevated to 0.5 times this parenthesis that is not exactly the parenthesis we had here at the production function. Okay, this is the difficult point for non-homogeneous production functions. These two gammas give me one gamma. Okay, gamma elevated to 0.5 times the same is gamma multiplied by L elevated to 0.5. All this is almost our function. What's the difference? The difference is that here we have 1 divided by the square root of gamma. And the key is to know that gamma is greater than 1. This is the key. As gamma is greater than 1, 2 divided by a number greater than 1 will be less than number 2. Okay? If I divide 2 by, for example, 1.5, 1.3, 1.7, the result will be less than 2. So I put less than, and here 2. What I find is the production function, and at the end my output is less than gamma times my output. Sorry. So we have decreasing returns to scale. It should be A. Okay, let's continue. I hope you've understand this. I know that for some of you these mathematical steps are not very, I know how to say it. You have problems with them, but you need to solve them, because this is very important for this type of exams. Okay. Then number 6. There are 6 firms, each one with total cost function 20 plus q squared, and another 10 firms with total cost equal to q plus 1 squared. The aggregate supply curve can be given by the following expression. Which one of these? Okay, we need to aggregate supplies. For the aggregation of supplies, we need first of all to know the individual supply of each firm. So type 1 individual supply. We know that individual supply comes from price equal to marginal cost, but not at any price, maybe. Okay, price equal to the marginal cost here is 2q. Okay, I put 1 because I am talking about type 1 firms, and if I isolate q1, sorry, I have q1 equal to p half. Here I can see that any price level can be substituted, so the price range is any price over 0. Okay, type 1 aggregate supply. There are 6 firms with this type of cost. So the 6 type 1 firms have the same individual supply, so I just need to multiply by 6. Okay, the total supply of group 1 type 1 firms is 6 times the supply of each firm, so 6 times p halves, so 3p. This is the aggregate supply for type 1 firms. We do the same with type 2 firms. Individual supply is P equal to marginal cost, so from Q plus 1 to the square, I take down the 2, the exponent, and we have P equal to 2 times Q plus 1. If I isolate Q2, we have P halves, and afterwards we carry 1 subtracting to the left. If I write Q2 in the left hand, we have Q2 equal to P half minus 1, with P greater or equal to 2. Why? Because we have to equalize this to 0. We have to find the intersection point with the vertical axis, with the P axis, and for that we equalize Q to 0. We find that P equal to 2 is that intersection point, so the firms, the type 2 firms, will not produce for prices lower than 2 because the quantity will be negative. Yeah. So type 2 aggregate supply. There are 10 firms, 10 identical firms with this individual supply function. Then Q2 is 10 times the small q2. So 10 times this function, if I calculate it, is 5p minus 10 for prices of, here's a mistake, for prices over 2. Okay, here's a little mistake. Then we need to aggregate. The aggregate supply now. Every firm doesn't supply its good at any price. We see that for prices between 0 and 2, only type 1 firms supply. For prices over 2, all the firms supply the good. So we need to be careful, and for prices between 0 and 2, only type 1 firms supply. For prices over 2, all the firms supply the good. So Q1 plus Q2. If we operate, Q1 was 3p. Here we have Q1 plus Q2 is 3p plus 5p, 8p minus 10. Okay, so option B is the correct, 3p until 2 and 8p minus 10 over 2. This is what? This is the correct one. Okay. Well, number 7, a firm with a production function f equal to the minimum of the 2Lk with prices of the inputs 1 and 1 wants to produce 1000 units of its output with the minimum cost. Its cost then will be, okay, we have the perfect complement exercise for cost minimization. Then it's, as I always tell you, it's very easy. We need to solve this problem. Okay, we need to minimize the costs. The costs are R1 times K plus wage 1 times labor force. So L plus K, subject to the production must be 1000. How do we solve this? Okay, as I told you in classes, 2L, we equalize it to K, and with this expansion path, it's called, we substitute it again at the constraint, at the production function, at the isoquant, better. So, if where we have 2L, we substitute and we write K, we have the minimum between K and K, that is K equal to 1000. So we should use 1000 units of K. If we go with k equal to 1000 here, we will find that L is 500. Okay, 500. Then the costs are, by substituting here, 500 plus 1000 is 1500 or 1500 euros or whatever. Okay, very easy whenever we have complements or fixed proportions is called also. Number 8. Okay, a firm that wants to minimize its costs always makes, well, be careful with this question, always makes this MRTS equal to the price ratio, to wage divided by rate. No, maybe it wanted to, but we know that sometimes this is not verified. I made you, I think, a similar question for test 1, yeah, with utility. MPL divided by MPK is the same that we have here. So this is the MRTS in absolute value is MPL divided by MPK. So this B says me the same as A. So it's also false. And this expression is the same. Also carrying MPK to the right, multiplying, and W to the left, dividing. So these are false because maybe a firm wants to do this, but sometimes the MRTS is not calculable. As in the 7th exercise, we couldn't calculate the MRTS for the fixed proportions production function complement, or in some other cases we know that the optimal point doesn't verify this. Okay, as we said in unit 1, maybe quasi-linear or something. Well, so be careful with this question number 8. Now, 9. At the AK plane that represents the combination of inputs that allow the firm producing the same amount of output is called, well, this is very easy. This is the definition of what an isoquant is. Okay, yes, we could make a graph or explain something if you want. That's the definition, and you should know it. In this case, if a firm produces with 60 units of X and 20 units of Y, maybe 60 units of capital and 20 of labor, it produces 1000 units of its output. Okay, and if instead it uses 20 units of X and 60 units of Y, maybe capital, here labor, I could read it before, it also produces 1000 of its output. So they lay at the same isoquant, and they tell me that that both points give me the same production function and production quantity. Okay, output quantity, isoquants. Okay, iso, the same quantity produced. Number 10. Which of the following is not an assumption of a perfectly competitive industry in the long run? Okay, many firms. This is an assumption. Okay, many firms. Free entry and exit of firms, of course. Perfect information, of course. So clearly, none of the above. Okay, so I will leave it here, make a little break, and we continue with question number 11. Okay, I wrote you here the typical assumptions of the perfect competition in the long run. These are the assumptions, and as a consequence, firms are price takers, and as firms are price takers, then it follows all the theory that we see in class. Okay, so we see the question number 11.